All right, today we're going to do part 2 on looking at molarity calculations. Last week we talked about molarity, how it's a way to discuss concentration, and we do it in terms of moles of solute per liters of solution. And last week we just worked with moles and either milliliters or liters. So the other type of question that we're going to focus on is when grams are involved, whether we're given grams or we're asked for grams, and somehow molarity is involved with the calculation. So in your note packet, we have one practice problem that we're going to go through, and then I'll go through the first 2 practice problems on the worksheet. So in the note packet, our question is find the molarity of 500 milliliters of a solution that contains 4.9 grams of dissolved sulfuric acid. So in this question, a couple of things. It's giving us the volume, okay, 500 milliliters, which we know that this is going to have to be in liters. So I'm going to end up dividing this by 1,000, which is going to give me 0.5 liters. Okay, it also gives me 4.9 grams, which looking at our molarity formula, well, grams isn't in there, so we're going to have to do an extra step here. And then it also tells us what the 4.9 grams, what the compound it is that it's coming from. So for this question, whenever you have grams, and then in this case, molarity involved, we're going to have to do it in 2 steps. And this goes back to something from a little bit earlier in the year, back in December, where we can find moles. Because if we look at the original molarity formula we used last week, it's in moles per liters. Right now we're in grams. So what we're going to have to first do is figure out how many moles are present when we have a certain number of grams, and that formula, which is in your reference table, is going to be moles is equal to grams over the GFM. So we're first going to have to use our grams to find moles, and then we'll have to plug moles into the molarity formula. And then just to review, when we do the GFM, it's going to be based on the formula. So for like this one, we have H2SO4. So I'm going to do 2 times 1.008 plus 1 times 32.07, or 32.1 if you round it to the tenths, and then plus 4 times 16.00. So if we get the GFM for this, I end up calculating 98.09, and that's how many grams there are per mole. Okay, so you're always going to have to, when you have grams involved, use the GFM or gram formula mass, either to start or at the end. So in this one, because we're given grams, we're going to start with just the mole formula. So we're going to have our moles that we're trying to find is equal to grams over its GFM. So moles is X here. The 4.9, the given grams, that's going to get plugged in the numerator. The GFM, the part that we added from the periodic table, always goes in the denominator. So that is our 98.9. And then our moles that we find, I get 0.05 moles. Now this is where you have to be careful, because some students will stop here because they think they're done. But it didn't ask for moles, it asked for molarity. So then I have to go into my next step. Molarity is moles per liter. Molarity is going to be 0.05. That's what I just figured out. So that's going to get plugged in. Over the liters, which we already put into liters, is 0.5. So then when you just divide those two, you end up getting 0.1 molar, or 0.1 moles per liter. Okay, so it's the same basic formula with molarity. However, we have this whole extra step here in order to convert grams to moles. So take a look at the worksheet that I attached. We'll say molarity practice part 2. I'm just going to go through these first 2. Now in number 1, they are looking for how many grams of potassium nitrate, and potassium nitrate is KNO3, are required to prepare 0.25 liters of a 0.7 molar solution. So with this one, the liters and molarity are going to allow us to find our moles. So that's going to be step 1. Okay, and then for moles, then we can go back in order to find our grams. So again, this is 2 steps involved. One little thing, the GFM of potassium nitrate, we're going to use 101.1 grams per mole for this. All right. So I said first, the information that we're given is liters and molarity. So that means I can use my molarity formula to start. So that's our molarity is equal to our moles over liters. We're given 0.7 molar, and moles is X, and liters is in the denominator. So you can simply, from that point, cross multiply. So X would be equal to 0.7 times 0.25, and that gives us 0.175. And you could round that off, but I got that in my calculator, so I'm just going to leave it. And then from there, remember, in this case, we're going to find grams. So we started with our molarity formula because we were given molarity in liters to find moles. And now I can use moles to find how many grams that would be. So moles, and I'm just using my second formula here, is my given mass, which is your grams that you're given, in this case that we're going to be looking for, over that GFM, which is always from the periodic table. So in this one, I have 0.175 moles. X is the number of grams I'm looking for, and then I told you we're using a GFM from the periodic table of 101.1. So X would just be cross multiplying those two. And when you do that, I'm just going to round off to the tenths here. I get 17.7 grams. Okay. So we did one solving for molarity. We did one solving for grams. So the last one I'm just going to practice with you is looking for volume. So in this one, I'm given 5 grams of KCl. I'm also given molarity, and I'm looking for volume. So when I look at this one, I know that eventually I'm going to need to use my molarity formula. Okay, this is what I'm going to be looking for. I'm given molarity, but I need to find moles. So the only way I can do that is to take my grams and get it into moles. So for this one, again, this would be one where as soon as you know you have grams and moles both involved here, we're going to need to know the GFM of KCl, which when you add that up, I'm just going to round this to the tenths. I get 74.6 grams per mole. So I'm going to start there. So we know that to calculate moles, we're going to have to do grams divided by the GFM. I'm looking for moles here. And then my given grams was 5 grams. That GFM from the periodic table was 74.6. And when I divide those two, I get 0.067 moles. Okay, now that I have moles, I can now go ahead and plug these in. So I have my 0.25 molar solution. I have 0.067 moles over X. Just to help you with the math here, most of you guys would probably initially cross multiply. So you'd get, I'm just going to put this over on the side for more room. You would get 0.25x is equal 0.067. And then this is the part that some of you guys struggle with. Look at what our x is. You have to take that number that is with x, divide both sides by it. Okay, that allows the 0.25s to cancel out. So you have x by itself, which is what we're trying to do. And then when you divide those two, I get 0.017 liters. And that would be my final answer. Okay, so these are definitely a little bit trickier than the kind of part one that we did with just moles and liters and molarity. It's just not that it's anything different, it's just adding on that extra step either when grams are given to you or when you're looking for grams. But both of these formulas up at the top here are given to you on the reference table, so no need to memorize, you just have to know how to use them.